Did you know that when scientists analyzed ancient DNA from Southeast Asia, they discovered that Thai people carried genetic traces from a civilization that existed 8,000 years ago and then completely vanished from the historical record? Did you know that despite speaking a language from China, most Thai genetic ancestry actually comes from ancient Southeast Asian populations that were already living in the region for thousands of years before any Chinese migration occurred? And did you know that Thai genetics show connections to populations as distant as Madagascar and the Pacific Islands, revealing ancient maritime trade networks that existed 2,000 years before European explorers reached these regions? Today, we're examining what recent genetic studies reveal about Thai origins, and the findings challenge everything historians thought they knew about Southeast Asian population history. In 2018, scientists extracted DNA from 8,000-year-old human remains found in caves across Southeast Asia. What they discovered was a population they named the Hobinhians, and their genetics were unlike anything seen before. These ancient people showed extraordinary genetic diversity. Individual skeletons contained ancestry from populations that existed thousands of miles apart. Some showed connections to early Europeans, others to East Asians, and still others to populations related to Australian Aboriginals and Papua New Guineans. The Hobinhians weren't just hunter-gatherers. Archaeological evidence shows they created sophisticated stone tools, developed complex burial practices, and established settlements that lasted for millennia. They dominated Southeast Asia from 12,000 to 4,000 years ago. But here's the crucial discovery. When geneticists analyzed modern Thai DNA, they found that approximately 40% of Thai ancestry traces back to these ancient Hobinhian populations. The mysterious civilization didn't vanish. Their descendants became part of the genetic foundation of modern Thailand. This Hobinhian ancestry appears throughout Southeast Asia today, but it's particularly concentrated in Thai populations, making them living repositories of some of humanity's most ancient and diverse genetic lineages. For decades, the Standard story claimed that Thai-speaking peoples migrated south from China around 2,000 years ago and replaced local populations. Recent genetic evidence reveals this narrative is only partially correct. The migration did happen. The O1A and O2AY chromosome markers associated with early Chinese farming populations appear at frequencies of 40 to 60% in modern Thai men. These genetic signatures clearly trace back to southern China and northern Vietnam. However, the replacement part of the story is completely wrong. Instead of conquering local populations, the Chinese migrants integrated with existing Southeast Asian groups through centuries of intermarriage. The genetic evidence shows that modern Thai people are roughly 60% descended from these Chinese migrants and 40% from pre-existing Southeast Asian populations. But this wasn't a simple two-way mix. It involved multiple waves of migration and complex population interactions over centuries. Mitochondrial DNA, which traces maternal lineages, tells an even more complex story. The B4, B5, and F haplogroups show connections not just to China, but to maritime populations across Southeast Asia and the Pacific. One of the most surprising discoveries involves ancient maritime connections. Thai genetics show clear evidence of contact with island populations across the Pacific and Indian Oceans, revealing sophisticated seafaring networks that existed thousands of years ago. The mitochondrial DNA haplogroup B401A appears in both Thai populations and Madagascar, separated by 4,000 miles of ocean. This same marker shows up in the Philippines, Indonesia, and Polynesia, suggesting ancient maritime trade routes connected these distant regions. Archaeological evidence supports this genetic story. Excavations in Thailand have uncovered bronze drums, glass beads, and ceramic styles that match artifacts found across maritime Southeast Asia. These weren't just trade goods, they represent cultural and genetic exchange networks. The Sa Huang culture, which existed along the Vietnamese coast from 1000 BCE to 200 CE, shows particularly strong connections to Thai populations. Genetic markers associated with this maritime culture appear throughout Thailand, especially in coastal regions. This maritime ancestry explains why some Thai populations carry genetic variants typically found in island Southeast Asia. despite Thailand being largely mainland territory. Before Thai languages dominated the region, much of Southeast Asia was inhabited by Austroasiatic speakers, the linguistic family that today includes Vietnamese, Khmer, and various minority languages throughout the region. Genetic analysis of modern Austroasiatic speakers reveals they carry some of the oldest population signatures in Southeast Asia. The Mon people of Thailand, who still speak an Austroasiatic language, show direct genetic continuity with populations that lived in the region 4,000 years ago. Crucially, broader Thai populations carry significant Austroasiatic genetic ancestry, even though they now speak a Tai-Kadai language. This represents linguistic replacement without genetic replacement. The languages changed, but the people remained. The Austroasiatic populations were among the world's first rice cultivators. Genetic studies show they developed sophisticated agricultural techniques and bronze-working technologies that later spread throughout Southeast Asia. Their genetic legacy includes adaptations to tropical agriculture that persist in Thai populations today. The M7 and M12 mitochondrial haplogroups, strongly associated with Austroasiatic populations, appear at frequencies of 15 to 25% in various Thai regions, demonstrating the continued presence of this ancient ancestry. From the 9th to the 15th centuries, much of what is now Thailand was part of the Khmer Empire, centered at Angkor in present-day Cambodia. This centuries-long political connection left clear genetic traces. Thai and Khmer populations show remarkably similar genetic profiles, but with important differences. Both carry the same basic mix of ancient Southeast Asian and Chinese ancestry, but in different proportions and with different additional components. The genetic evidence suggests that Thai and Khmer identities emerged from the same ancient Southeast Asian population base, then diverged through different patterns of migration and cultural development. They weren't separate peoples who competed for territory. They were related populations who developed distinct languages and political systems. Certain Thai populations, particularly those in regions longest under Khmer control, show elevated frequencies of the R1, a haplogroup associated with South Asian populations. This reflects the Khmer Empire's adoption of Hindu-Buddhist culture and its connections to Indian civilization. Y chromosome analysis reveals that about 5 to 10% of Thai paternal lineages show South Asian connections, likely dating to the Khmer period when Indian merchants, priests, and craftsmen established communities throughout the empire. Thai genetics reveal fascinating adaptations to tropical diseases that have shaped the population for thousands of years. These adaptations provide insights into both ancient health challenges and modern medical applications. Malaria resistance shows the clearest patterns. The HBE variant, which provides protection against malaria, appears at frequencies of 15 to 30% in different Thai regions, correlating directly with historical malaria distribution. Areas with the longest history of malaria exposure show the highest frequencies of protective variants. Dengue fever resistance involves more complex genetic patterns. Multiple genes involved in immune response show signatures of natural selection in Thai populations, suggesting long-term adaptation to mosquito-borne diseases. The G6PD gene, which affects red blood cell metabolism, shows interesting regional variations in Thailand. Certain variants provide malaria protection, but can cause complications with specific medications, information that's crucial for modern personalized medicine approaches. Thai populations also show genetic adaptations to dietary patterns. The AMY1 gene, which produces an enzyme for starch digestion, appears in multiple copies in Thai populations, reflecting thousands of years of rice-based agriculture. Thailand's geography has created distinct genetic regions that preserve different aspects of the country's complex population history. These regional differences reveal how geography, culture, and history interact to shape genetic patterns. Northern Thai populations show the strongest Chinese genetic influence, with Y chromosome markers like O1 reaching frequencies of 60 to 70%. This reflects both the original southern migration routes and continued cultural connections with southern China. Northeastern Thailand, Isan, shows stronger connections to Lao and Austroasiatic populations. The region's distinct cultural identity corresponds to genetic patterns that differ measurably from central Thailand. Southern Thai populations show the strongest maritime Southeast Asian connections. Mitochondrial DNA markers associated with island populations appear at higher frequencies, reflecting ancient seafaring networks and trade connections. Central Thailand represents a genetic crossroads where northern, northeastern, southern, and ancient influences converge. This region shows the most balanced representation of all major ancestral components. Despite these regional differences, all Thai populations share fundamental genetic similarities that distinguish them from neighboring populations and reflect their shared ancient heritage. Contemporary genetic research on Thai populations is revealing practical applications for medicine, agriculture, and understanding human evolution. These discoveries have implications far beyond academic research. Pharmacogenomics studies show that Thai populations metabolize certain medications differently than European or East Asian populations. The CYP2D6 gene, crucial for processing many common drugs, shows variant frequencies in Thai populations that require adjusted dosing for optimal treatment. Agricultural genetics research reveals that traditional Thai rice varieties contain genetic adaptations that match human genetic patterns. Both the rice and the people adapted together over thousands of years, creating integrated agricultural systems. Modern Thailand's urbanization is creating new genetic patterns as regional populations intermarry. Bangkok has become a genetic melting pot where historically separated Thai populations are recombining, creating genetic diversity not seen for centuries. The Thai diaspora, now numbering over 1 million people worldwide, maintains genetic distinctiveness while contributing to genetic diversity in their new home countries. Studies of Thai Americans show persistent genetic signatures even after multiple generations of mixing. Thai genetics reveal a population history far more complex than traditional narratives suggested. Rather than simple migration and replacement, Thai origins involve multiple waves of ancient settlement, sophisticated maritime networks, agricultural innovations, and cultural adaptations spanning thousands of years. The genetic evidence shows that Thai people are descendants of some of Southeast Asia's earliest inhabitants, Chinese agricultural migrants, ancient maritime traders, and various smaller population groups that contributed to the region's genetic diversity over millennia. I hope you enjoyed this video. Do like and subscribe to our channel Medieval Mind for more videos like this.